Welcome to the continuation of what we had started with Uncle Hakim. Of course, Uncle, your only Uncle, the national Uncle, your Uncle, our Uncle, their Uncle, everybody's Uncle. So now, today's lesson, we are going to look at irrational numbers. In the previous lesson, we looked at rational numbers. Now we are going to look at their cousins, irrational numbers. Our lesson is irrational numbers. What is an irrational number? That's the question that you should have. If you know the definition for rational number, no need to panic. It's just simply exact the opposite. So we said the rational number is a number that can be expressed in form of A over B. But in this case, we are saying an irrational number is a number that cannot be expressed as A over B. So the keyword is cannot be expressed as A over B. B, of course, not equal to 0. A and B relatively prime. So we won't take much of your time to discuss this. We talked about relatively prime in the previous video. So now it's just that an irrational number is just the opposite of that. So there are those kind of numbers that you cannot write in form of A over B, and those are called irrational numbers. So now the main focus is how to prove that this is a rational number. There is no proof that has been proven to say you can prove that this is a rational number, not at all. So the only way to prove that this is an irrational number is to try to prove if it's rational. Then if it fails to be a rational number, then automatically it's irrational. Yes, you got me right. There is no proof that can directly show you that this is a rational number. But you prove this by trying to prove that it is rational. Then when it fails to be rational, then automatically your conclusion will be it is irrational. So there is no proof at all. That will tell you that this proof will tell you that this is. So we prove this by contradiction. So we prove this by contradiction. So we prove this, we only prove irrational by contradiction. So we prove irrational by contradiction. How? By assuming the given number, by assuming that the given number is rational. Then if a given number fails to be rational, then automatically we are going to say it's irrational. So there is no proof under the sun so far, unless the people we sit in Germany discuss as mathematicians, then agree that this is a proof for irrational. But we only use proof by contradiction, where you try to prove that it is rational. Then from there, that's where we'll conclude to say, if it fails to prove that it's rational, then automatically it is irrational. So let's pick a few examples that we use. So we're going to just look at two examples. Prove that root 2 is irrational. So that's the first one that we will do. That is number one. Then the second one we'll see. So your proof, now this is your solution. So you start, we prove this by contradiction. We prove this by contradiction. What's the meaning of contradiction? If you say something and then you do the opposite, it means you're contradicting your statement. Okay, so we prove this by contradiction. So we we assume that square root of 2 is rational. So that's what our assumption is. We assume that square root of 2 is rational and can be expressed as a over b, where b is not 0. Of course, since we are saying it's rational, we are saying it can be expressed as a over b, where b is not equal to 0. At the same time, a and b are relatively prime. So if you forget this terminology, relatively prime, you can say have no common factor. Have no common factor. So you're saying it has been written in its simplest form such that a and b have no common factor. So now, if you don't want to write relatively prime, you can replace relatively prime with have no common factor. This is standard. Wherever you're proving this, you have to write this statement. It's from this statement that's where you can conclude. Without making this assumption, without stating this, everything you're going to do, even if you know how to do it, it will be in vain because it means it's pointless. What are you going to conclude? Where are you going to get the conclusion from? So this you have to always write. If you want, you can borrow my words. For now, for those that are sitting for the exam, you can borrow my words, but make sure that you know how to go about it. So this is how you do it. So now, since we've said this can be expressed as, so we are going to say, what we've just said is we've read this square root of 2 be equal to a over b. Yes, that's what we've said. So now, if we've done that, we need to remove the square root and make one of the two, of course, subjects. So now, from there, this will be square root of, okay, let me just go downwards, okay, so that we are not losing track of one another. So we are going to have square root of 2 equals a over b, okay, a over b. Then we say you square both sides so as to remove the root, the root, so that this is 2 is equals to a squared over b squared. Then cross multiply, this will turn out to be 2b squared equals a squared. Okay, so now this a and b, I forgot to mention they are integers. This a and b are integers. So now, one property of integers that everyone should know is that if I get an integer, square it, I'll get another integer. For example, if I get 2, square 2, that will be 4. I'll get another integer. And now that integer, if this number that I squared is divisible by 2, the result will also be divisible by 2. If this number that I square is divisible by 3, then this will also be divisible by 3, the 9. If I get a 4, square it, get 16, the answer that I get will also be divisible by that. If I get 7, square it, this is divisible by 7, I'll get 49. 49 will be divisible by 7. So what we have here, and this number can only be, so it means this a squared, since it can be written as b squared to the power 2, we are saying if this a squared is written as 2b squared, it means this a squared is divisible by 2 because it has been expressed as 2 times a certain b squared. So what it implies here is that we have a squared, and a squared is divisible or has a factor. Let's use simpler terms. Let's just from there, let's use simple terminology, straightforward terminology. So from what we have here, we are saying let's call this one from 1, a squared as a factor 2, or is divisible. The good term is divisible, but for your easier understanding, you can say as a factor 2. But it is divisible. When a number is divisible by a certain number, it means that number is a factor of that number. Divisible by 2. As a factor 2. And I said if that number which you get here is divisible by 3, it means even the number before you squared it, it was divisible by 3. So what it implies is that hence before the a was squared, hence a is as a factor, a also as a factor, a also as a factor 2. So get this right. If a squared, this a squared can be written as 2b squared, it means this a squared as a factor 2e. And it implies that even before this a was squared, just the ordinary a, it means that it also has a factor 2 from the properties of integers. This is how integers work. So now, if you have that, now take note, just that the board seems to be small, but we'll continue from there. So what we are saying is, since we have a squared be written as 2b squared, what we are saying is a squared as a factor 2. This 2, because of the 2b squared. Then, given a as a factor 2, or in other words, a is divisible by 2 as well. So it means we are going to say a can be written as a can be expressed as a is equals to 2 times c, where c is another integer. So it means a can be expressed as 2c. Since it's as a factor, it's divisible by 2. It means it can be expressed as 2c. So now we are going to replace in this equation, in this first equation, we are going to replace where there is a, we are going to replace a with 2c, because we are saying this a can be expressed as 2c. So we're going to say 2c squared is equals to 2b squared. That we are going to replace that from equation 1. So we substitute in equation 1. So you can just say we substitute a with 2c in equation 1 to get this. So apapali a, tuwafunyapo a n'okubikapo 2c. That's what we have. So this is what we have. Then you can say 2 to the power 2, because this square is for both 2 and c. We're going to have 4c squared is equals to 2b squared. Then b will divide through by 2 so that b remains around 2. So that b squared is equals to 2 in there, that gives 2. So it will be 2c squared. So b squared has also been expressed as that. So it means b squared as a factor 2, hence even b as a factor 2. So now take note, here we are saying a as a factor 2, b as a factor 2. This means that a and b, this means a and b have a common factor. A and b have a common factor 2, which Now, before I make a statement there, let's go to the previous page. We made an assumption that A and B, remember, that's why I told you this statement always needs to be there. We said A and B are relatively prime, and we said have no common factor. But we've just seen that they have a factor 2. So if they have a factor 2, it means we have a contradiction. This means A and B have a factor 2, which contradicts our assumption. That this square root of assumption that this can be expressed as A over B. So it contradicts because there is a factor. Hence, by contradiction, square root of 2. Hence, by contradiction, root of 2 is irrational. Simple as that. Just that. So it's irrational. Since it has a common factor, it's irrational. It cannot be expressed as A over B. It's irrational. Simple as that. So that's how you prove for irrational. So this has been proved that this is irrational by contradiction. So that's how you prove it. If you have a question, you can follow us through Z Study, leave a comment, find a way you can talk to Uncle Hakim, then they'll be able to connect you. Okay, so let's move to the second example. Another example is this. So this example can come in 2 ways. They'll tell you that using the fact that this is that. But we're not going to use the fact yet. We're just going to do it direct. So example 2 is prove that square root of 2 plus square root of 3 is irrational. Like I said, there is no method of proving that this is irrational, so you prove by contradiction. So we prove by contradiction. Okay. So we prove by contradiction. We'll say assume, or we rate. So we assume that square root of 2 plus root 3 is rational and can be expressed as A over B, where B is not 0. A and B are integers, and A and B are relatively prime. A and B are relatively prime. Okay, so that's our assumption. So we are going to say square root of 2 plus root 3 is equals to A over B. Okay, so we've said that. Then the target, first of all, is to remove the roots. So we are going to square root both ends. Please take note, when squaring, put in brackets, then square. So that will be, even this side, A over B, you square. So now when you square that, it means that you square that, you get 2. You square that, you get 3. Then you multiply 2 times root 2 times root 2 times root 3. That's how you expand that. Square that, you get that. Square that, you get that. this times that times that. If you want, you can do it the other way, but that is more easier. A squared over b squared. So 2 plus 3, that gives us 5, plus 2. What's under the root can multiply, so that will give you root 6. Then this is equals to a squared over b squared. Okay. Then you can take the 5 the other side. You can take the 5 the other side. So what you do is you have 2 square root of 6 is equals to a squared over b squared minus 5. Then you can have 2 square root of 6. Yeah. Then this is a squared minus 5b squared over b squared. Then you divide both ends by 2, so that what you have is square root of 6 is equals to a squared minus 5b squared over 2b squared. So if they told you that given the fact that root 6 is irrational, you end there and conclude that what we have this side is a rational number. Why this side is a rational number is this is an integer. When you square an integer, you get an integer. This is an integer. This is an integer. When you multiply two integers, you get an integer. When you subtract integer, so this result is integer. So one thing that you have to know is a squared minus 5b squared is an integer. Even 2b squared, that is also an integer. So if you want, you can even say, let c denote this integer a squared minus 5b squared, because this is an integer and c is an integer. So it means this square root of 6 will be written as c over, and you say that 2 d, let's get a d, b equal to 2b squared, and that is also an integer. So you substitute to say this will give me an integer that, this will give me an integer c, then over d. So you have expressed this as c over d. So this is an integer. So if they told you that using the fact that root 6 is irrational, then you end there. But now since they have not told you that, then you're going to start from there, just the normal procedure. Now you have to prove that this is rational. So we assume that this is rational. So from there, we are going to assume root 6 is rational and is expressed as c over d, where c and d, we just said these are integers. C and d have no common factor, Okay, so if c and d have no common factor, what you do now is we have that square root of 6 is equals to c over d. Then you are going to square both ends. So you square this side, you also square this side, so that what you get is 6 is equals to c squared over d squared. Then you can have c squared is equals to 6d squared. And now when you have this is the same thing that we had for that equation 1. Remember, this is what we talked about in the previous question. So what we have is, we are saying c squared is equals to 6d squared. This implies that c squared has a factor 6. Hence, even c before it was squared, it has a factor 6. Even c as a factor 6. So c will be written as 6e. where E is also an integer. You have to say when you introduce a new letter, you say that's an integer. So it implies that we are going to replace in this equation where there is C, we'll replace with 6E. So we are saying this will be 6E. Then you square it, it will be 6D squared. Then that will be 36E squared is equals to 6D squared. Then you want D to remain alone, you divide by 6, so that D squared is equals to 6E squared. And remember, this is D squared, it has been written as 6E squared. This implies that D squared as a factor 6, which means even D before it was squared also has a factor 6. And now take a look at this. We are saying D, we said C as a factor 6. We've now just said D as a factor 6. So there is a common factor, which is 6. This contradicts our assumption. This contradicts our assumption that C and D have no common factor. So square root of 6 is irrational. Hence, even root of 2 plus root of 3 is irrational by contradiction. So this is irrational by contradiction. Look at that. There we said C and D have no common factor. And then now we just seen that there is a common factor there. So this has indeed given us a contradiction. So that marks the end of our today's lesson on irrational numbers, proving irrational numbers. Thank you for watching us. Invite more friends to subscribe to Z Study. Get in touch, if possible, with Uncle Hakim for more questions. Enjoy Z Study. Share with your friends, those that are yet to come to university, those that are planning to do A-levels at any university, School of Business, share, School of Mathematics, share. This is the stuff that you all do. Thank you very much. This has been a lesson with Uncle Hakim. Have a blessed day.